off before 13.3. You guys did the book worksheet, so here's the practice sheet. Let's just review some of this, okay? I'll do a few problems. You guys can do the rest for homework. Let's see, write each other measure in radians. So we're going from degrees to radians. How do we do that? Yes, kids. We multiply by pi over 180. Okay, so 45 degrees times pi over 180. Put that in your calculators and vape it. $45 divided by 180, hit math, enter, enter. Pi over 4. Let's do number 3. Negative 150 times pi over 180. Negative 5 pi over 6. All right, I think you get the idea there. All right, 6 through 9, we're going from radians to degrees. So you're going to multiply by 180 over pi. Pi over 6 times 180 over pi. Actually, 6 goes in the 180, 30. Pi's cancel out, 30 degrees. Okay, so remember arc length? Sure you do. Arc length equals radius times theta, which is the central angle. I wish it was like this all year. All right, number 9. 7 pi over 8 is theta. There's my radius. So arc length equals radius times theta. 7 pi over 8. You should be able to do this in your head. 4 goes in the 8 twice, so 7 pi over 2. Number 11. Now, be careful with number 11, okay? They're asking for arc length W. Okay. That was arc length A, by the way, up there. So, we need the central angle here, though. They didn't give it to us. We need to find that central angle. They did give us the central angle for this arc length, which is 5 pi over 6. Now, how many degrees in a circle? 360. Okay, we have 360 degrees in a circle. Now, we could just take 360 minus 5 pi over 6, and that will give us the measurement of this central angle. There's different ways of doing this. What's 360 in radian measure? Well, we just did that up here. Degrees to radians, you multiply it by pi over 180. So 1 full circle is how many radian measures? 2 pi in radian measures, okay? So I know that the whole thing is 2 pi. Find this angle, we could just take 2 pi and subtract 5 pi over 6. Well, what do we need to subtract fractions? That's right, a common denominator. This time it's going to be 6. How do I make this denominator 6? Well, you multiply it by 6, which means I have to multiply the numerator by 6, and I get 12 pi minus 5 pi. So the measure of this central angle is 7 pi over 6. Okay. So the arc length of W equals my radius, which is 4, times theta, which is 7 pi over 6. Again, you should be able to do this in your head. 2 goes into 4 twice. 2 goes into 6 3. 2 times 7 pi, 14 pi over 3. Questions, comments, concerns? All right, flip it over. We got to do the clockwise that we skipped. Okay, the minute hand of a clock is 8 inches long. So that's my radius, right? What's the distance does the tip of the minute hand travel in 10 minutes? Now, there's different ways of doing this. Okay, here's 12, 1, 2, 3, 4, 5, 6. So they're asking us from 12 to travel 10 minutes, which goes to 2. Okay. Now, we know what the radius is, 8, right? 8 inches. We have to find theta. Any ideas? A couple different ways we can do this. Best way would be, have your unit circle in front of you, and you can kind of figure out what theta is. But if you don't, we do know that 1/4 of a circle is 90 degrees, right? Right. 90 degrees. So we could just take our 90 degrees, change it to radian measure, pi over 180, which equals pi over 2. So that's pi over 2. Or you can do it this way. Okay, we're going to have 2/3 of pi over 2. Thank you. Yeah. Okay, so 2/3 of pi over 2. So we're going to take 2/3 times pi over 2. Okay, 2/3 of my 90 degrees. And if I cancel out the 2's, I get pi over 3. So theta equals pi over 3. Then I'm going to put in my formula. Arc length equals my radius times theta, which is pi over 3. There's nothing to cancel out. So I went 8 pi over 3 for my travel. Again, if you use your unit circle, you would notice that this is 60 degrees. Or 2/3 of 90 degrees is 60. That's what pi over 3 is. Actually, that one was kind of easy. The next one, a little harder, because you have to do some thinking. What distance does the tip of the minute hand travel in 3 hours and 3¼ hours? That 3 means that that minute hand went 1, 2, 3 complete circles. What's that in radian measure? 3 complete circles in radian measure. So you're going to multiply 3. What's 1 circle in radian measure? We just did this. 2 pi. 3 times 2 pi. 6 pi. And we have to add, what's a quarter hour? What's that 90 degrees? Did that already too. Pi over 2. So we're going to take our 6 pi and add our pi over 2. And again, we have to make that 6 pi over 1 into denominator 2. So I'm multiplying by 2. I get 12 pi over 2, which is 6 pi. 12 pi over 2 plus pi over 2 is 1 pi over 2 is 13 pi over 2. So that's the distance of theta. All right, so let's put it in our formula. I'm sorry, that's just the angle measurement. So my radius is 8 times central angle, 13 pi over 2. And 2 goes in the 8 4 times. 4 times 13, 52 pi. That's the arc length it travels. That's on your test. On, was this 4th hour? Friday, May 31st. And we're not going to do C. You guys can do 14. Um, 16 is not that bad. Okay, scientist studies two aliens shown to the right. The distance from the sun and Earth to the equator is 3960. So that's the radius. What is the measure in radians of the central angle? Well, we're going to change 12 degrees into radians, right? So this is A. We're going to change 12 degrees into radian, which is pi over 180. 12 1/80ths. 1/15, so I have pi over 15. Okay, so our central angle is going to be pi over 15. It wants to know the distance of this arc length. So that's going to be our radius, which is 3960 times pi over 15, sorry. 3960 divided by 15, 264. And I don't care about 16 through 19. You guys should be able to do 20. Questions, comments, concerns?